Hi everyone, my name is Yuan Rui, and today I will do the presentation for our crime dataset analysis project. Okay, to begin with, we're now living in a fast-paced society, so we are surrounded by a lot of crime news every day, and we know there are different crime rates in different regions, and it's more important to understand why they are like this difference. So historically, we may use methods like track boards to understand different contribution factors that may result to crime rates in a region. But with the new technology development, we can try to use data science, which can be a revolutionary tool to predict the crime rates in certain region. So in order to achieve that data science tool, we need to understand the demographic factors and how they connect with the crime rates. So we could understand demographic factors on both individual level and society level. For each person, they will definitely have characteristics like age, gender, ethnicity, religion, education, occupation, income, etc. And when we aggregate this kind of information or the data to the society level, we can also see in the society how is the percentage of different age groups and how is the diversity of different ethnicity groups, like their percentage again. And then we can also see different numbers for different education levels and different numbers from different professional or the jobs, etc. And they are also numbers on the household ownership, rental fees, etc. So it can all reflect on the demographic factors in that region. And our project goal is to use the regression model that can intake those input data, which are demographic factors in the region, and output a prediction like whether the crime rate will be above or below the national average in that region. So we have been provided a data set that has around 147 attributes, including 125 predictive variables, 4 non-predictive variables, and 18 potential goal-oriented variables. So in total, we have over 2,000 instances. So this abundant data gives us a lot of information, and we can choose to explore different features and to design a good model for the prediction. So I actually grouped the column names in several categories, and we also have the example of the column names in each of the category. So we have population, that is generally the population of that community, and ethnicity is all percentage of population in a certain race. For example, we have percentage Black, percentage white, and for age, it's the percentage population that is in certain age group. We have age that are between 12 to 21, 12 to 29, or about 65. So for income, as just the per capita income. is purely numerical values. And for education, we have the percentage of people with certain degrees, such as bachelor, high school, etc. For housing, we are also having examples such as the house vacant, the house occupied, house owned, etc. For immigration, there are columns like percentage speaking English only, percentage not speaking English well, and percentage foreign born, etc. For crime types, we have violent crimes, non-violent crimes, and we also have very specific types of crimes like murder, rapes, robbery, etc. So we first conducted data cleaning in the projects, including duplicates, identification, manipulation of the data types, and handling missing values. So for duplicates, we basically find duplicates in the city names, and we enhance the recognition of data by combining city and state. So both information columns together. And we also changed certain data type, certain columns data types to numerical, and change certain columns to factor. For handling missing value, we basically replace them with the mean of the respective variable. For data visualization, we first tried group by and aggregate the counts of the crime numbers per population, and we actually identify an outlier in the DC state for the violent crime counts. And we also tried scatter plot for the crime count distribution on the US state map. So it's very vivid to see the different darkness of the color represent the number of counts for the crimes. And we can identify certain states have much higher count for the violent crimes, and some states have much higher counts for the non-violent crimes. Then we also interested in understanding the correlation of our different factor variable data. So we can see that the positive correlated variable to the violent crime count can include the race percentage Black and the percentage unemployed. But we also see that the mid-income as well as percentage bachelor degree or more is negatively correlated to the violent crime counts. So here comes to our design of the logistic regression model. And basically, logistic regression is a statistical method used for binary classification. So outcome variable is categorical, has two possible classes, and the dependent variable will basically use that logistic function. And it's suitable for us to use logistic regression because we exactly having a binary outcome, and we can interpret the coefficients in terms of odds ratios, and it can handle non-linearity. So it's the good model we try to use in this problem. And we've taken the steps for our logistic regression model construction, including defining the national average of the crime rates and create a binary variable to say it's above or below national average. And then we define the dependent variable we use, and we check the model prediction and threshold. We finally evaluated the variable significance and the model fits. So we actually choose 6 independent variables in the end, includes population, the race percentage Black, median income, percentage of unemployed, percentage of population with bachelor degree or higher, and finally number of vacant household. And we also have their correlation plots on the left side here. We have this national average of crime rates being calculated, and we have the new column named violent crimes above or below average as a binary variable, which is 0, 1. And we split the data set to 70% training, 30% testing. And dependent variable we define as violent crime per 100K population count. It just represents total number of violent crimes per 100K population. We utilize the logistic regression to obtain a predicted value between 0 and 1. And we have threshold at 0.5, which means above 0.5, we will reclassify as 1. Otherwise, it will be set to 0. And we will basically examine the p-value of variables and identify statistically insignificant variables and assess the performance by comparing non-deviance with residual deviance. And the lower residual deviance will suggest a model with independent variables superior to a constant model with no variables. Here we have our regression results on the training data. So we can view the coefficients of our independent variable. We can see the p-values, and then we can see the deviance in the chi-squared test, etc. Similarly, we also have the results on the testing data. To interpret our regression results, we have these few bullet points. So the overall model significance appears to be statistical significant, indicated by highly significant chi-square test for the entire model, and p-value is essentially 0. For variable significance, each predictor variable is individually significant and predicting the response variable, and they all have very small p-values associated with them. Then for deviance reduction, each variable suggests that including these predictors improves the model's fits to the data. Then for now versus residual deviance, the residual deviance is substantially lower than the known deviance for each added variable, indicating the model with predictors is a better fit than the null model. And the significance, the small significance codes suggest strong evidence against null hypothesis. So for conclusion, the results suggest the logistic regression model with specified predictor variables is performing well. We also tried the PCA in trying to understand the dimension of the input data. So PC1 explains around 40% of the total variance. PC2 explains an additional 26%. And the cumulative proportion reached around 68% with PC2. So these two components capture a substantial amount of variability in the data. The PCA results suggest a substantial amount of variability in the data can be captured by a reduced set of principal components, and the reduction in dimensionality can be useful for further analysis, visualization, or modeling. So we can focus on the most important patterns in the data and potentially reducing noise or redundancy. So this could be next steps for the projects. But back to our existing logistic regression model, we calculated the error rate by comparing the actual value to the reclassified predicted value, and we get the accuracy as around 81.45%. So this model is actually relatively simple, but it's producing very good results. So we're saying it's actually very effective to classify the outcomes and for a substantial portion of the data set. In conclusion, these projects contributes a deeper understanding of the complex relationship between demographic factors and crime rates. And leveraging the data analysis, statistical testing, and machine learning techniques, the findings aim to serve as a valuable resource for stakeholders dedicated to reducing crime and foster safer communities across the United States. And thanks again for listening to my presentation. It's a pleasure to take this class, and here I welcome any questions. Thanks.